and I'm the president of the QLD branch. This is our first seminar. It's the third month of the year, but I think with everything that happens, it has been quite hard to find somebody to present. We are waiting for the locusts for the next pharaonic thing. I would like to introduce Richard, who is from Melbourne currently, Federation University. Before that, he did a PhD in 2015 in Griffith University. Then he went to London School of Tropical Medicine, then to Washington State University, and now to the Federation University. And I was really intrigued, I should say, by the title, which is Linking Heterogeneous Human Cognition with Household Financial Stress in an Agent-Based Model, Livestock Vaccine Decision-Making among the Global Poor. And I thought human cognition, household finance stress, and livestock vaccine, that's an interesting title. I would never have thought that it would come together.
Yeah.
So I'm looking forward to see what you have to say. Thank you.
Thank you. Yeah, obviously, firstly, thank you for the opportunity to present in person, online, and if for those watching later via the recording. Yes, it's a long title, and B, there's quite a bit packed in there. And so this is a sort of a seminar that is part retrospective, covering the current state of a model that we have, an agent-based model, and then it's part also sort of conceptual with some ideas of how we plan to take this model forward. And also this is part of an introduction to agent-based modeling. I'm not sure how familiar the audience is with agent-based modeling. I was just at Griffith University with a group of economists, and they knew nothing about agent-based modeling. So I appreciate that perhaps many of you are more familiar, but forgive me if I go a little bit slow through some of the basics of agent-based modeling for this. So just some acknowledgements of, firstly, some co-authors with two existing papers. Craig is a vet, and Eric is an epidemiologist. Offer is a GIS geographer. All three of them are from Washington State University and have made important contributions to our work. And then also to people, some key individuals in Kenya, where I've collected empirical data that will inform some of the calibration that we seek to do in this model, and who've also made some helpful inputs on disease modelling with respect to livestock diseases. So indebted to those contributions and some funding that got us underway. I appreciate that. So starting again, giving differing audiences and their backgrounds, I suppose simulation models are a bit more au fait within the health sciences. So I don't perhaps need to explain and justify why I would be dabbling in, as an economist, in simulation models. A bit more was needed for the economists to make that point. But evidently, a whole raft of different types of epidemiological models are run in simulation, and a range of different types of simulation environments, and they have a lot of interesting, important policy information and feedback that can be used. And that's the case for the model that we've built, is wanting to ultimately build a model that is policy relevant, but we are wanting, as a social scientist, wanting to sort of try and make an attempt to progress how we model within a simulation framework human decision making. And so that's sort of my interest, in addition to the hopeful outcomes of being policy relevant, is sort of a methodological one to push those boundaries. And I suppose, why do they, in my opinion, need to be pushed? To the extent that I'm familiar with various epi models, particularly with respect to malaria in low-income countries, these models obviously aren't geared towards really saying much about human agents, but I think the modeling would be could be improved and enhanced, certainly more complicated, if there was a layer of actually including and being able to manipulate in across a population of human agents, different behavior traits beyond just some sort of decision tree, beyond some sort of assumptions about optimizing sort of agents in terms of their decision making. So I think there's a space there, and I'll outline that as we go. Why livestock and why the poor? That's probably maybe less immediately obvious. Well, it's pretty clear that much of the world's poor are livestock dependent in terms of income. So when you look at maps, I haven't got any here today, but you look at maps of density of livestock around the world, it's highly correlated with poor income countries as well. And so many of the world's poor have small herds, maybe even individual animals that they're reliant on in some sense for income. And within economics, just as a side note, there's a growing literature around using randomized control trials to actually identify the income effects of gifting livestock to ultra poor households, particularly households that are female headed. So there's growing literature around that, and I'll talk a bit more about that literature and how this modelling may complement some of that work. So just again, just as far as a background to motivate this idea of looking at why we are interested in looking at livestock and the global poor. Some work done by former colleagues, also based in Kenya, identified that effectively having more productive livestock was beneficial, more than just beneficial, contributed to further human capital gains for girls in rural Kenya. So in particular, they modelled, I think it was East Coast fever, a livestock disease, particularly among dairy cattle, and having animals that are more fully vaccinated against that. What were the income effects of that? And in turn, how did that impact on household decision making? In the context that even government education into secondary schools is not free in Kenya, and one pattern of behaviour is that girls often in these households are the first to be removed from school when household incomes are deemed to be not sufficient to keep those people in education. With respect to this, some of the papers that have conducted randomized control trials, Banerjee is the Banerjee of Nobel laureate of 2 years ago. His 2015 paper was in Science, and it is actually a series of 6 studies around the world in South Asia, Africa, primarily, and they had a fairly, I would say, a strict set of behavioural requirements around participants in this study. Okay, and those, so you could argue, development literature, it's fairly paternalistic sort of policy that will give you a single goat or a cow, but if you get that in a part of our study, you can't sell the animal. You'll have forced, in some cases, forced savings, so you won't have autonomy as to how you use the money that you get from milking the animals in particular. There's a lot of fairly intensive home visits to keep people in the program, to make sure that they're abiding by the various regimes that they had running. And the animals, lastly, they were all fully vaccinated. Okay, it's a fairly wide range of livestock diseases. So that's fine. That's part of the study, and the authors are really fairly clear about that. But it does beg the question as to how helpful are these results in terms of trying to extrapolate the assumed or the shown benefit of having livestock to other populations who, in particular, may not be able to follow the same behavioural regime. And so this is a study. Heifer International is an NGO that sort of reason for being is to gift livestock to ultra-poor households, hence their name. And since the study came across where there's actually no set behavioural requirements for households who receive goats, for example, in a North Indian state. And perhaps not surprisingly, there's a whole range of effects that really worked against this program. Households often sold their animals at suboptimal ages and weights, so didn't really realise the full potential of that asset. Diseases spread pretty quickly across animals that were introduced to these communities. Well, there was environmental effects where, with an influx of goats, people were sort of obviously trying to get free foraging resources, and so had negative environmental effects as well. And so, in a sense, I came into this project seeing these two extremes of a really strict, highly regimented control trial, and something on the other end of the spectrum where actually the effect is perhaps fairly negligible of actually giving the same assets to poor households. And so this sort of contrast raised, sort of in my mind, prompted me to think, what other methods do we have to actually have some insight into this issue, into people's behaviour and how that affects their decision making. Okay, so that's, I want to just go through these three parts of outline a little bit about agent-based modelling, and in particular a bit of the behavioural economics that is sort of underpinning this work, a section of just detailing some of the preliminaries of the model as it currently exists, and then spend just a little time of just sort of conceptually identifying paths that we are looking to take for the next step to actually really build out the next stage of this model. So the scarcity thesis is a fairly dominant one in behavioural economics, and it really simply says that real or perceived financial stress is a tax on cognitive, what they call bandwidth. The idea being that each individual may have a different bandwidth of capacity that they can operate cognitively, and that this living in or perceived to be living in financial stress acts as a tax, as sort of a subconscious worry or stressor that limits that bandwidth, that capacity to process cognitive information. So that's the premise of this thesis that has been tested a few times, and there's mixed results. There's a US study that finds no effect, so it's a bit of a debated point, but certainly in low-income countries, there's more data to support this. And it gives rise to the question of, well, a bit of the who cares question. What does that mean for decision making? That's fine. Maybe this hypothesis is true, and my bandwidth is limited when I'm under financial stress, but does it actually have an impact for my decision making? That's an empirical question that is still, I think, clearly outstanding, but an interesting one that a lot of some people are giving some attention to. Further within economics, there's Haushofer and Ferrer is a review, again in Science, that looked at in particular the effects of not just cognitive capacity changes, but affect, it's a sort of emotional state also associated with poverty, and the effect that it has on risk preferences, okay, of households. So again, within economics, that would be a key motivator for understanding behaviours, whether it's setting up businesses, whether it's perhaps in a health context, risky behaviours. They summarise literature and argue that there is a pretty clear a clear set of studies supporting that. So this is, I just wanted to then sort of locate where we in this paper published last year, we sort of identify one particular decision model that we use as a submodel within our agent-based model. And I want to locate that within a fairly, I think, a broad range of different types, different conceptions of decision-making within agent-based models. So you can see there, the standard econ fully rational optimizing agents, fairly easy to sort of to create and run. And so there's some certain advantages of that. Again, within sort of the psych and behavioral economics is a sort of bounded rationality view of decision-making. There's satisficing, this term coined by Herb Simon, about people that really just sort of maximizing their well-being in a decision up to a certain unobservable threshold. So some sort of satisfactory level that they deem, and then anything beyond that, they're stopping to really process how good, they're not ranking perhaps the full set of options. They've found one that suits them, and they'll stop there. And so that would be perhaps classed as a form of a heuristic that's used in decision-making. Dual processing theory is very much relates to the thinking fast and slow of Kahneman and Tversky, plus others have a lot to say about this idea of how rational are agents in reality. Moving quite distinct, point 4 there, a lot of models take a very different approach and in them have aspects of learning. Agents have memory and so are fairly adaptive within a limited range. And various algorithms are used to inform the decision making. The last one's probably the smallest, but it's the one that we're going to draw on that we do draw on in our paper. Econ physics, a fairly niche area, but the Schelling paper there, let me just introduce that. That's the segregation model of Thomas Schelling, where he modeled looking at the sort of the sociology of why in America, Caucasian and African American neighborhoods are often quite segregated by choice. And so he ran and proposed sort of a logic in being able to identify an early model. People have retrospectively gone back and identified he's probably used something like an Ising model coming from the physics literature. Bouchard is the author that we draw on, who first proposed the model that we use, and I'll outline that in a moment. So that's where we're sort of fitting, I suppose, in some spectrum of alternates for decision making. I won't go into too much detail about, in particular, what this Ising model is. I'll outline it shortly, but different permutations of it, and et cetera, et cetera. But so I'm just going to pause there, and I'll, as I said, I'll come back and introduce the random field or Ising model as we use it shortly. This is more for econ, but agent-based modeling, in my mind, perhaps got its first go. Most certainly, in my reading in ecology, ecologists have a lot to say and use agent-based modeling or individual-based modeling a lot. Obviously looking at different issues compared to social scientists. And there's limited traction within economics about using agent-based models. But let me just say that to the extent that agent-based models provide an alternative to what we call the representative agent, in macro models, we just have basically everything sums down to one individual that's assumed, and these macro models are based on that one individual. And so ABMs are getting traction in that space because they provide an alternative. So some details about the current model as it is, and it's referred to as the pastoral scape model, and it's very much located within a specific environment and geographical region. You can see there in sort of central Kenya, the individuals who are modeled, who are agents in our model, some of them are what may be referred to as agro-pastoralists. So I won't go into a whole lot of detail, but they're semi-nomadic. They, at periods of the year, they take their herds and they move around the landscape to enable their herds to find better foraging conditions. And so that's an important context of our model. And we're modeling in different ways two diseases, Rift Valley fever and contagious bovine pneumonia. You can see there, we're using those two because they're present in that environment, but also because they have different sort of frequency of vaccinations that are required. One is a once for life, one's an annual booster. And so we're interested in seeing, with the use of our model, decision model, what effect that frequency has on outcomes. Okay, so just very quickly, we have three set of agents. The first and third there are perhaps the most important. We are simplifying households right down to one single person, head of household, who is genderless, and at this stage sort of a fairly just a unit, just a generic agent. And we have cattle, and my colleague has built this model to model individual animals that have ages, genders, have their own life cycles. And that in itself is, I've learned through working with a computer scientist, there's no easy feat to get a model that sort of works. You don't have a herd of just one bull all by itself, and you have a herd that sort of is realistic within a different life cycle of these agents. This then is just outlining the different sub-models of our agent-based model. Okay, and so those in the blue headings are sub-models that currently exist. So we have a decision model around Rift Valley fever and CVPP vaccination decisions. Come to explain that shortly. We have an epi model, which is just using some transition probabilities for these two diseases, livestock diseases. We have our animals that move, so we have a movement submodel, and that's driven by foraging conditions that, so once they reach a threshold, sort of forces out these herds to move around a landscape. We have life cycles of our animals, and then we're using historical data, foraging condition data, to drive both the movements, but also then, in certain respects, the dynamics of the life cycle of our livestock. In drought conditions, cattle aren't fertile, they go dormant, and they come back. So all that is sort of built in due to the data that we have from the foraging conditions. Where we're going is building into a socioeconomic sort of sub-model into this, where the realization of herd sizes goes into and is realized in terms of income, and then how that then feeds back into cognition parameters that we have in our agent-based model. Okay, so that's what it is now, and then the dark socioeconomic is where we're sort of wanting to go. So part of the challenge, obviously I can't go into detail about all these aspects, but and that's the benefit and the curse of agent-based models, is their complexity and the many moving parts that exist. So this is the random field Ising model that we're using, and so let me just walk through this. So this is a probabilistic model, so we're dealing with, in a sense, with utility as a function of time. And we have three broad components, the small f, subscript I, large F, T, and then we have a network, which is effectively a social network. And this is where has different applications in physics. But so the last term there on the right-hand side is a social network. We have heads of households that are part of a network within their village. We have a set number of villages located. At the moment, that's effectively turned off. It's all evenly weighted, and there's no real information flowing through that network. But as far as the random field Ising model as a concept, that capacity is there. The large F is defined certainly by Bouchard as being perhaps a public information channel of information to all households. And then the first term is a sort of an endogenous, a willingness of the agent at hand, how they're predisposed towards a particular issue. So we can think about vaccinations, we can think about COVID. Some individuals, even before we start, are sort of more pro or more against a decision before we even start. And so that's another feature as defined by Bouchard that can be used within this Ising field model. So what we're doing, we actually, for the model that currently sits, we've effectively turned off all those channels in the random field Ising model. Bouchard then proposes that we take a logit transformation of this And we're interested for our purposes in these two parameters, mu and beta, that are introduced. And mu is defined as being sort of basically a memory. It's a weighting of the influence of the last decision on my decision. So decision in time t, and the weighting that I give the decision in t-1. The weighting that one gives to that past decision is controlled by mu. And then the beta is sort of defined as a bit of a noise parameter. And Bouchard then argues that perhaps it could be interpreted as a rationality parameter for this. And so we've taken Bouchard's proposal, and we've basically set this decision model up within our agent-based model. And the paper then goes on to basically then just test across various parameter spaces of mu and beta, the sensitivity to of our agents to actually choosing to vaccinate or not for each of these two livestock diseases. Okay, and so at the moment there's no calibration involved. It's really just identifying that parameter space, and you know the sort of perceived utility of progressing this model further. As I've said before, the agent-based model, it's very much a spatial model. We have agents moving around, and so we have a particular grid space that, and the environmental data that we use comes from a particular region in central Kenya that I identified before. And again, I think I mentioned it in that sort of flow diagram of sub-models. We're using foraging condition. Foraging condition is just NDVI, but a more nuanced version of NDVI. So NDVI being sort of the foliage, if you like, based on satellite imaging. So infrared, sort of the greenness of some land, but it doesn't capture the difference between grass and trees. There's some problems with the specific use of it for cattle. And so this foraging condition index takes that NDVI, and then with some other data about soil conditions and some other inputs, just sort of transforms that into perhaps a more readily applicable measure of foraging conditions for animals. They measure it right across parts of East Africa from various universities in the States. And so we're using that data for our, across a particular time period, you can see there. So here the transition probabilities for each of our two livestock diseases. Then the issue with we found with then trying to, how do you institute this livestock disease into the model? Is it sort of a synthetic, it just occurs, or is there some other sort of rationale as to how and when livestock this disease breaks out in the model? And so we don't have a ready solution for the CBPP because it's not really environmentally driven, but Rift Valley fever has a high correlation to rainfall and mosquito populations. And so thanks to contribution of one of our co-authors, we use this probability sort of function across a time period. So in Kenya, there's 2 rainy seasons, a short rain and a long rain, and so this gives us an ability to introduce a Rift Valley fever at a more appropriate time within the time step of our model, and with varying degrees of likelihood. So that's how we institute that disease. So one point that we've come across literature that certainly uses agent-based models and certainly has more nuanced human decision models. To our knowledge, certainly some of these models would use a Markov chain as a way of allowing the decision in T-1 to influence the decision in period T. So that's good. Where this is distinct is that we have the ability to weight the degree to which the decision in period T-1 actually affects the decision-making in period T. So it is a distinct way of using memory, I suppose, in a model. And so that's just a point of distinction, just a point of note, I suppose. This figure, and we're coming to the end of what our current model sort of really offers, and I'll move into where we're wanting to go and welcome people's feedback on it all, certainly. So this then, with the other figure that I'll come to next, is really identifying the parameter spaces of particular interest for us with respect to mu and beta. And in particular, we argue that the subplots there of E and F show a nice sort of, we could refer to as convergence at a nice rate that enable, you can see it perhaps more readily here, as mu changes and it gets to about 0.35-ish. There's still some slight movements, but it gets fairly stable. We have a population that's affected by CBPP at a fairly stable level, and this model is done with beta held at 0.1, and we can see then that the distinction between Rift Valley fever, which is the yellow, my colours aren't that great, is the orange line, and then what is note also of CBPP, the number of deaths of our animals, just with the changing of this memory weighting for the contribution the last decision has on my current decision. And so we can see with Rift Valley fever as a once for life vaccination, that memory is less important. I'm making these decisions less frequently, while the CBPP is an annual booster that's required, and the efficacy really doesn't even last for the 12 months. The efficacy sort of drops off about six or 8 months. But we see here then that where mu is closer to 0, where I have greater memory, the weighting is given at a higher level, then I see in our model that we have more deaths as associated with that. So the decision not to vaccinate is more prevalent and carries forward to my next decision whether I should vaccinate or not. And so in this area, vaccinations are not mandatory here in this part of the world, and people have to pay. They're heavily subsidised by the government, but they're not free. And so hence the decision of the head of household, of the person who owns these livestock is important. So this is, again, just coming back to our parameter space and trying to identify where within this spectrum, in this case of mu, we want to perhaps be focusing our attention as we develop this model further. So just going forward, so picking up on our behavioural economics, we're going to start by building sort of a two-good economy. Let me just jump to this slide first. We're going to build a two-good economy that is based on livestock and crops, and they will be the only sources of income for our households. Crops will be a fairly standard, yield minus the demand of the household calorie intake in this model. But the income then of cattle will be affected by obviously herd size, how many animals are alive in our model, and their health. The third component, we're going to start with a fixed endowment of assets that will be unchanging over the time. So that's a strong assumption. It's not a really realistic assumption, but for us to be able to isolate the income effects of just cattle and realizing the value of cattle, we want to do that. With having household wealth, then we can get estimates of Gini coefficients and the distribution, the sort of levels of equality or inequality across at the start point of our model, as opposed to at the end point. So that's in short. And so we're going to use this threshold. We're going to start with a threshold of like 50% of the household's wealth, their assets plus their income, as determined by the initial setup of those variables. And we're going to have a sort of a close to symmetric, but not quite symmetrical fall and rise in these, like a step function in the beta parameter, this noise, this rationality parameter. We're going to start by looking at that. with these parameters at the moment, our model, everything is uniform. All agents have the same parameters of cognition, but we would start then having the upper threshold, this bandwidth will differ across our individuals. They'll have higher upper limits of both potentially mu and beta. And so that will be their starting point. And so the individuals will move at the same step, but be moving in different intervals to account for differing cognitive capacity among the population. And I should point out that what will inform this will be data that I've collected. So in 2017-18, collected 3 rounds of household data from the same villages that we model. So while it's not perfect for a number of reasons, but we do have a basis for getting a distribution of some of these cognition parameters to start with. We have that survey data that I collected was at the end of a severe drought. So we have sort of some information about the improvement in some of these cognition parameters, but we don't have the other side going into the drought and that decline. So we have something to help calibrate going forward, but certainly not as much as we would like. And that's sort of how we'll go. And I can outline those cognition parameters, the data, what tests I use. I was just looking at one of those posters over there, that monotony and speed of not too dissimilar for some of that. Yeah, so I think I'll just pause there and open up for questions. For those interested, the code is available at that location on my colleague's GitHub account. So you can see various versions of our code, how we've changed it and the like. And that's my contact details. So I'll leave it there, and thank you.
Thank you very much, Rita. Does anyone have any questions?
Yeah, so you said it's not calibrated, so you can't. I'm wondering how you can validate it. How you can.
That's what I was thinking. How do you validate such a model? Because you have been talking about estimating these parameters as inputs rather than as outputs. So is there a way of validating your predictions? Will you have historic data to say, I'm trying to model this existing situation in the past?
Yeah.
And see.
Yeah, the short answer is, if there is, relevant data, we don't have access to it, and I'd question with a lot of the data. So we don't have carrying capacity of what the herd populations in this area. We don't have a whole lot of different measures to work with, and certainly in such sort of a relatively high frequency sampling or surveying, we don't have that data. So yeah, so that's an outstanding question, I suppose.
So the answer is you cannot really validate it.
No, well, we haven't identified how we could validate it.
I suppose there are some models that will just be rejected because they're illogical.
Sure.
And there are others that will be more reasonable.
Yeah, it is. I mean, so we're taking baby steps, really sort of, we think, fairly incremental steps in how we're developing this, and that's motivated by an awareness of some of the challenges and having too many moving parts and a lack of data to calibrate it and validate it. But yeah, we've got something, and we'll work with the decision, at least with the human aspect of the decision model, as far as we can go. And we may pause it there and put it on the shelf. Not sure.
I suppose there are things you can do where you can pull a lever or change something in the model, and you say, well, okay, well, if we do this, we'd expect this output.
Yeah.
And if that happens repeatedly for all the changes,
that's one way we would thinking about going is using some of this CRT data that's not in our context, geographical context, but they've got some certain returns, quite a bit of data across a wide spectrum of nutritional intake of households, of income, savings, a whole range. So seeing if our model, if we had fully rational, we took out these parameters, these cognition, and we had the strict sort of confines of their randomized control trial, would we get anything like the income returns that they report across at least six different, geographical areas? Possibly starting with that, and then sort of stepping out. Okay, well, we hopefully get something in the ballpark that our model is capturing something that's of note, and then sort of trying to loosen one at a time, so, introducing these parameters, having them fairly dynamic, and seeing how they work, and really not being able to validate the results, but just identifying to what magnitude are we seeing differences in results, at least to say, well, what we know about individual behaviour among the poor is such, and these factors seem to be relevant for further studies and things. So that's one possible of stepping forward.
Any questions from the online people? Assuming you can hear us.
Yeah, I mean, just picking up on that, sorry, we'll away. Yeah, it reminds me of like, phase 1 studies where people do stuff in Petri dishes, and it maybe informs the next stage.
Yeah.
It feels like it's more about informing or filtering some early ideas into then things that could be tested in trials. Is that what you think?
Yeah, well, that's possible. I mean, working predominantly in sort of development, health and low income, I know big studies, randomized control trials in North India that were sort of poorly conceived, and then the negative results, millions of dollars spent by Gates and others on different aspects of healthcare markets in North India. And there's perhaps a whole range of reasons why the initial hypothesis didn't work out. But certainly you could argue that even having, with its funders, some level of, some generic filters that proposals need to sort of satisfy in some way as a justification for certainly the social sciences, where you don't have any sort of, you don't have a progress, you don't have a sort of a pathway of developing your concept before you reach the trial status. It's really just in social sciences, I've got the idea and someone's willing to fund it, whether it's an NGO or so, and I just run it and we'll just see what happens. So within those domains, that process in the social sciences is probably not really optimal. Whether we'll be able to have anything to contribute to that, but there's certainly a lot of wasted money as randomized. These trials gain footing within the social sciences for good reason, but
Anyone else? I have a question. It might sound very naive, but
this is the worst question.
why did you choose an agent-based model, in the sense that couldn't you go on an aggregate level of, say, a population of humans, and that's on average what's going to happen, the same with the cattle and so on? Why did you? Because if you were to simulate a country or a region, you will need to simulate thousands of cattle and thousands of people. That will be computationally expensive. You will need a lot of memory because you need to keep track of all these agents. And at the end of the day, will you gain more from modeling the population rather than the individual?
Yeah, no, you're right, absolutely, with the sort of demands, the number of agents and the period of time and the number of steps and decisions everyone's making, it does get slow. And when running it repeatedly, I think at the outset, the agent-based modeling approach, the opportunity to identify, well, certainly having the more dynamic disease profile was important, and I thought that the agent-based modeling would be a good way of being able to model that disease spread. And I thought that, based on my on the beginning of basically that being sort of cancelled out within some of these randomized control trials over pretty short periods of time, 2 or 3 years, that there's not a whole lot of scope for seeing that dynamic at play. And with that, then being able to really be being able to introduce the heterogeneity in terms of types of households. When we perhaps made our heads of households, we have them gendered, and we have female heads of households and male heads of households. Well, those dynamics are very different, and I perhaps naively thought that the agent-based modelling would be the most flexible to enable them to be able to pull out those sort of more dynamics, more interplay. So that's so the interaction of animals we thought was important. So a lot of livestock modelling, I'm more familiar with that than human health, don't actually model the individual animals. They just sort of have a herd and have one herd here, and the herds may move as a whole, and that's fine. But when you come to then realise, I would argue, when you come to realise the value of those herds, the way I treat male versus the female cow is very different, and the age profile of the animal is very different. And so therefore I hope to get better, more accurate income returns and realizations when I've got individual animals as opposed to just a generic herd that may have prescribed characteristics.
So how long does this model take to run? And how many individuals do you use? Because I saw somewhere like n equals 60 or something.
Yeah, so we have 5 villages. Each village has 20 heads of household. So they're only human, well, in terms of what we're talking about, only human agents. And then each head of household has a herd. And at the moment, it's a uniform, all herds are the same size.
Oh.
You've got me, I think it's like 20, but I'm not, I'd have to check.
Yeah, no.
So the time, I don't know, because I haven't run it. That's my colleague runs it, and he will be able to clearly tell you. But
How long does it take to run, and for what period of time do you know? It's okay if you don't.
no, I don't know. So his interest in this model, he's from one of the national labs. He's not interested on recording. He may be interested in the policy, but his interest is in actually the computer science of making it easier, making the learning and use of agent-based models simpler for policymakers. So he's all about, yes, efficiency and of how the model works, and being able to better enable academics and policymakers to sort of engage with agent-based models without the huge learning curve of programming languages. And so anyway, so no, I don't know the time, but that's part of his interest in the project, I can say. So he's cognizant of it, but yeah.